So hello and welcome back again. Good morning and Jai Shri Ram, Jai Shri Radhe. You are watching this video on our YouTube platform Govind Chemistry. Hope everyone is doing good. So myself Govind Chemistry mentor. So I am recording this video because thermodynamics series is going on in my channel, and today it will be completed. So this video will be the last video for thermodynamics, and after that we'll see what we have to start. So this is the last video for thermodynamics. Hope this thermodynamics series is helpful for you and you people uh, take knowledge from there. It is helpful for your NEET exam, JEE exam. So all the very best, my dear students, and watch the video. So this is the last video number 15. Thank you. So as I said that this is the last video number 15, but it is not 15, it's a video number 16, children. Okay. In the thermodynamics series, this is the last video and the number is 16, lecture number 16. So Gibbs free energy we have completed in the last video. Now we are going to discuss about the standard Gibbs free energy change. Standard Gibbs free energy change. So for standard, it will be represented at G naught, delta Z naught, that we can measure, because delta G only we can measure, it's a state function. At standard means at temperature 298 Kelvin and pressure 1 atm. If you are measuring Gibbs free energy at 298 Kelvin temperature and 1 atm pressure, then it is standard Gibbs free energy. Why it is required, children? Because the thing is, temperature and pressure condition varies in different places. Suppose if it is not there, then you are measuring any process spontaneous here, and that process in America, it will be non-spontaneous because of temperature and pressure condition. So that is why scientists set a standard value for delta G that is accepted by every country, every place. Okay, so delta G R naught, that is means standard Gibbs free energy for reaction, is equal to standard enthalpy of reaction T delta SR, standard entropy change of reaction. Suppose any reaction is given A plus 2B, it gives 2C plus 3D. So what is the enthalpy standard Gibbs free energy for that? Delta G naught for product minus standard Gibbs free energy change for reactant. That formula we will use. Okay, like equation is given I2 solid plus H2S gas, it is forming 2HI gas plus sulfur solid. In Gibbs free energy for formation, standard HI solid, gas, is equal to 1.8 kilojoule per mole. H2S gas 30 kilojoule mole inverse. Find delta G naught of reaction. So how to find? One thing you can note here, just like in the enthalpy we tell you, delta G naught of formation of element in standard state means 298 Kelvin temperature and 1 atm pressure, or you can say commonly observed state, that will be 0, is 0. Like for Cl2 0, Br2 is available in liquid state, so 0, I2 in solid 0, O2 gas 0, like that. These are the standard Gibbs free energy change for formation. Okay, so come to the question. In that question, so how to find delta G is equal to delta G naught for formation of product minus delta G formation of reactant. So here standard state, here standard state, and remaining two are given, so put the value. So here 2, so 2 into 1.8 minus 30, so it will be whatever, it will be in minus. Process is spontaneous. Got it? So that process will be spontaneous. Now question is given, question number 2, methane gas plus 2O2 is forming CO2 gas plus 2H2O liquid. Here some values are given. Delta HF naught for CH4 minus 75 kilojoule per mole, not given for this. CO2 minus 400 kilojoule per mole, minus 300 kilojoule per mole. Delta entropy 180 joule mole Kelvin, joule per mole Kelvin, same here, 200 same, 220, and here 70, and temperature is 298 Kelvin. They are asking standard Gibbs free energy of reaction. So how to do, children? We know the formula for reaction is equal to minus T delta. So delta HR, enthalpy of reaction, is equal to enthalpy of formation for product minus enthalpy of formation for reactant. Put the value here. So 2 into enthalpy of formation of product, water. So 2 into minus 300 plus 1 into minus 400 minus 75 for this, and here it will be 0. So from here whatever will come you can calculate, and in standard entropy change for reaction, standard entropy for product minus standard entropy for reactant. So similarly 70 product 70 it will be 70 plus 220, 70 plus 220 minus 180 plus 200, reactant and product. Then you can easily find out delta G. In this formula you can put the value, temperature is given. So that is the question. Now come to the relation between delta G naught relation with equilibrium constant for delta G. Relation with equilibrium constant. So one reaction is given, A plus 2B 3C plus D. What is the Q for that? Q means what? Q is called reaction quotient. Concentration of C की power 3, D की power 1, A की power 1 and B की power, basically it is the active mass of C, D, A, B. Okay. What is the difference between reaction quotient and equilibrium constant, children? So very small difference, that reaction quotient is defined for any time, but equilibrium constant is defined at after the equilibrium. For this reaction, any time you can find out reaction quotient. Reaction started, after 2 seconds you can find out, after 10 seconds, after half an hour you can find out. But equilibrium constant defined after the equilibrium only. So here you can write, can be defined at any stage of reaction. So if we measure Q at equilibrium, then Kc is equal to Q. So here equilibrium constant same value, c की power 3 d a b की power 2. So at the equilibrium children, kc, that means q is equal to equilibrium constant. That's it. If you are defining it at equilibrium, then reaction quotient is equal to equilibrium constant. So what we know, that delta G relation we know. Next thing, delta G is equal to delta G naught plus RT log Q, that we know. So at equilibrium children, Q is equal to equilibrium constant, and at the equilibrium delta G value 0. So put the value, 0 is equal to G naught plus RT log E and equilibrium constant at the place of Q, equilibrium constant. So from here delta G naught is equal to RT log E. So that is the relation. You can convert it into base 10 also. Delta G naught is equal to minus 2.303 RT base 10 K. That is the relation. So one question we will solve and finish this lecture. Question is JEE 2007. A to B, this is the reaction. Delta for reaction is given minus 54.07 kilojoule per mole. (10 joule Kelvin mole). And one more thing is given, 2.303 into 8.314, 298 is equal to 5705. Why they given I don't know, this value is given. Find I am not getting proper place, some many disturbance. Log K base 10. Options are 5, 10, 95, 100. So what we know? We know delta G naught is equal to minus 2.303 RT log K. So delta G naught, you have to find out delta G naught. So delta G naught, how to find? By this reaction. Here I am solving. So delta G naught for reaction is equal to delta G naught of formation for product This formula not work. That formula is equal to minus T delta SR naught. Temperature 298 here given somewhere. So here it will be minus 54.07 minus 298 and into 10. Okay, so it will be, it is in kilojoule converted into joule, so it will be minus 54070 minus 2980 joule. Now you can put the value here, subtract it, then you will get 5705 is equal to minus, this is also minus 2.303 into R 8.314 into T 298 log K, minus minus cancel, and here it value is given 0. So here cancel because same value given. So what is the answer? Here it is, one more zero is coming, so here it is coming 10. So ultimately what you are getting, 10 is equal to log K. That is the value they are asking. B option will be correct. So like that question they will ask. So here children, this thermodynamics is completed. Hope you enjoyed, and all the very best. Thank you.